Let's now look at solving the inequations. Okay. I still reckon the easiest way of solving inequations, 2 simple steps. Find those critical points and then just test the regions. Bing, and you get the answer straight away. Now, of course, the simplest type are linear ones. I suppose they're the first type we looked at, which we just solve like a normal equation. But remember, if you change the sign, you change the sign. Very good. Quadratic inequations and any polynomial in general, of course. So let's do a quadratic one. 6 minus 5x minus x squared is greater than 0. I personally prefer the coefficient of x squared to be positive. I don't know. It's just easier to factorise, I think. But again, change the sign, change the sign. So it becomes less than 0. That factorises. So I know that 6 and 1 are our critical points. That would be a concave, which way? Well, if I'm looking at my second line, yes, it's up. But either way, it shouldn't really matter, as long as you read it correctly. So on the second line, I'm saying it's concave up. When is it below? But I could use the first line. The first line is concave down, but I'm saying when is it above? It would give me the same answer. And so I'm in between minus 6 and 1. So there's my solution. And of course, any polynomial can be solved like that. Draw the polynomial and see when is it above, when is it below. Okay, absolute value inequations we looked at. So let's recap those. And it all comes from the definition of an absolute value. Remember, the absolute value of a number, it's either A or minus A, depending on whether A is positive or whether A is negative. So when we're solving one like this, we say, well, either the positive of 3x plus 2 or the negative, because it can be one of those two things. It's either A or minus A. And then we solve each of those. So the first one gives me x is greater than or equal to minus a third. The second one gives me x is less than or equal to negative 1. But it gives me the 2 critical points. And again, I can just test to make sure if I want to, or I can read off my solutions. I've got x is greater than or equal to minus a third. X is less than or equal to minus 1. So it looks like my solution is indeed that. Both of those, or the union of those. Then we come to the controversial one, where you all love to do your method of squaring the denominator. So we get 2 on x plus 3. Bottom of the fraction tells us the discontinuity. So there's our first critical point. Solve it like it's an equation. Minus 13 on 5. There's our second critical point. Now we just test. And, well, okay, sub 0 into that. What do we get? 2/3 is less than 5. Is that true? Yep. Of course it is. Yes, yes. So 0 is included. Right. But, of course, they can be turned in, everything can be turned into quadratic inequations. Well, not everything, but these last ones can be turned into quadratic inequations. So here's the absolute value one. All I've got to do is square both sides. There we go. 3x plus 2 squared. It's not going to change the greater than or equal to 1. And we create the quadratic inequality, and we end up with the same solution. With the pronumeral in the denominator, of course, we do that horrible method that you love. Okay. If we multiply both sides by the square of the denominator, because we're multiplying by a square, we know that's positive, so we don't have to worry about the inequality sign. And and by the way, don't expand out. Alright, that's just waste time. I mean, you've already got a common factor of x plus 3, so when you bring it to the other side, you pull out the common factor, it's grouping in pairs effectively. We get x plus 3, 5x plus 13, and there's our same answer. Of course, we could use the graph to solve an equation, and that was the idea we talked about yesterday. Left hand minus right hand side, when is it above the axis, when is it below the axis, that sort of idea. So function x greater than g of x can be done exactly the same way. So when is function x above g of x? So if I had something like this, absolute value of 5x minus 3 is greater than x plus 2. Well, I could draw in the absolute value graph. There it is there. I could draw in y equals x plus 2. And we're now just asking ourselves, when is the absolute value graph above the straight line? Now, if you've drawn an accurate graph, you can read it off if the answers are nice integer solutions, but it doesn't look like that right-hand one is. So you're probably still going to have to solve it, but you just solve it like it is an equation to find those critical points. So we get 5 on 4 and 1/6. So we now know the critical points, and we can see when the absolute value curve is on that. Less than minus 1/6, the absolute value is above the line, and greater than 5 on 4. Now, of course, if we're not talking about an exam, if we're just talking about doing our work, you've got your graphing packages that can make this idea a lot more attractive because you can usually put the cursor on the point and it'll come up with the answer. Okay. 3D. 3E.